Hi students, today we are going to discuss an AC circuit containing a pure resistor and then followed by inductor and a capacitor. So first we will investigate a circuit which contains only a pure resistor across which a source of AC voltage is applied. Now in all such derivations, what we have to do is we have to derive an expression for the instantaneous current, because the current applied as well as the voltage applied to the circuit is alternating current. That means it is not having a fixed value. So the value of the current will be different at a different instance of time. At a particular instant, the current flowing through the circuit is called as instantaneous current. And the voltage applied also is alternating. So this is also, the left side is V. V is called as instantaneous voltage. So what we are going to do is, we will derive the relationship between the instantaneous voltage and the instantaneous current. So we want to find the phase relationship between the current and voltage in AC circuits. So we will begin the derivation with the given information, the instantaneous voltage. So I will write instantaneous voltage. That means the voltage at every instant of time is given by this V is equal to V maximum into sine of omega into t. So this is equation number 1. Here Vm is called the maximum value attained by the voltage, because we have studied that the voltage is represented by a sine wave. Sine 0 is 0 and sine 90 is equal to 1. Sine pi, that is 180, is also equal to 0. Like that, the sine value is changing. Accordingly, the voltage also will be changing. So the maximum value attained by the voltage is called as Vm. This is equation 1. Now, corresponding to this instantaneous voltage, there will be some instantaneous current. I will say that small I is the instantaneous current in the circuit. So now when this current is flowing through the resistor at any instant, the product of I into R equal to a potential drop. A potential difference, okay, will be dropped across this resistance. So the potential drop across the resistance, potential drop across the resistance R is given by small v is equal to this I into R. I into R. So these two are the voltages in the circuit. Therefore, by applying Kirchhoff's, by applying Kirchhoff's loop rule, according to Kirchhoff's loop rule, the net voltage in the circuit is equal to 0. Therefore, this Vm into sine of omega t minus I into R must be equal to 0. This is from Kirchhoff's second rule or loop rule. So I will take this Vm into sine of omega t is now equal to IR on the right side. Or I can take this IR on the left hand side. IR is equal to Vm into sine of omega into t. Or once again I need an expression for the current I. So this is equal to Vm divided by R into sine of omega into t. So you can see this equation I is equal to Vm divided by R into sine of omega t. Now R is a constant we know, and Vm is the maximum value attained by the voltage, that also is a constant. Naturally Vm by R must be some constant. So when I compare this equation, so I can write the same equation. Now I is equal to I maximum into sine of omega t. So this is another equation number 2, where I have substituted where Im is equal to, Im is equal to V maximum divided by R. So I compare this equation with the Ohm's law. Current I is equal to voltage by resistance. Therefore, this Im which is equal to Vm by R must be equal to the maximum value attained by the current in the circuit. So this is also Im is called as the peak value. It is called as the peak value of current. Peak value of the current. Just like Vm is the peak value of the voltage, here Im is the peak value of the current. Now I see from equation 1 and 2. So separately I will highlight these two equations 1 and 2. In equation 1 you see that the voltage is expressed as a sine function, and in equation 2 current is also represented as a sine function. So from equation 1 and 2 I find that the voltage as well as the current both are expressed as a sine of omega t. That means both are in phase with each other. Okay students? So from equations 1 and 2, it is found that V is in phase with the current. It is in phase with the current. What do you mean by saying that voltage is in phase with current? Whenever the voltage is 0, current also is 0. Whenever the voltage attains the positive maximum, current also attains the positive maximum. Similarly, both will attain the negative maximum and 0 at the same instant. So they are in phase with each other. So what is the phase difference between voltage and current in a resistive circuit? When there is no phase difference only, they will be in phase with each other. So phase difference is equal to 0. So I am going to represent this first in terms of waves. Okay, and then in terms of phasor diagram. So first in terms of waveform I am going to represent. So when you represent this in the waveform, you take a scale and draw neatly the phase angles. So this is voltage as well as current, both are taken along the y-axis, and this is the phase angle omega into t. So I will take equal intervals like this. Now in such waveforms always you follow the same procedure. That is, first voltage graph you have to draw. So voltage graph I am drawing now. This is the voltage graph. The current also is in phase with voltage. So the current is represented by another color like this. But the amplitude of current, you will see that it is lesser than that of the voltage. Because V is equal to I into R. Therefore, the magnitude of V should be greater than that of the magnitude of the current I. So here you will see this value is V maximum, and this value is I maximum. So this is I maximum. So the phase angles 0. One waveform will be over at 2 pi. First 0 and 2 pi. Then this midpoint is pi. This is pi by 2. And this is 3 pi by 2. So this diagram is called the waveform. Okay, this is called the waveform, which represents the phase relationship between the voltage and the current. So from this graph we can easily understand that whenever the voltage is 0, current also is attaining 0 value. And whenever the voltage is maximum, current also is attaining the maximum value. Similarly, the negative maximum at the 0. So they are in phase with each other. Now, the same thing also can be expressed in terms of a rotating vector. A rotating vector is only called as a phasor. This phasor is a vector which is rotating preferably in the anti-clockwise direction. So I am going to represent the phasor diagram also. Now you will see that in the phasor diagram, the voltage phasor and the current phasor both are in the same direction. Both are in the same direction. And the phase angle of voltage and current, you can see the phase angle of the current is omega t, and the phase angle of voltage also is what? Omega into t. So omega t is shown like this. So first this is for the current. So this is the current phasor. So this is current. And the voltage phasor. The voltage phasor is little greater in magnitude than that of the current. So we have to represent like this. So in this picture, you see that this is origin O, and this is I will take first OA is the voltage phasor and OB is the current phasor. And the angle between these two is what? Omega into t. Now, the length of this phasor OB, okay, length of this phasor OB, I will write this OB equal to, the length is what? Current, the maximum value of current. Similarly, the length of OA must be equal to the maximum value of the voltage. So, from this picture, we find that both the current and voltage are in phase with each other. So, this red vector is V, and this blue vector is what? I. Suppose if you project this on the y-axis like this, on this y-axis as well as the x-axis like this, when you project, you see that this I maximum, okay, this I maximum OB makes an angle omega t with the x-axis, and that is a 90 minus omega t along the y-axis. So this height must be equal to I maximum into sine of omega into t. Similarly, from here, this height, so this must be equal to what? This height must be equal to V maximum into sine of omega into t. So this is the phase diagram in which the vector is rotating in the anti-clockwise direction with an angular velocity omega or angular frequency omega. So this OB, length OB is equal to current maximum, and the length OA is equal to the voltage maximum. So IM is called the peak value of the current, and VM is called the peak value of the voltage. So from these two diagrams we find that the current and voltage both are in phase with each other.